Hi everyone, this video is on question 8 of exercise 9G from PO2. So the interesting part of this question is actually part A, because part B is just an ordinary question in the when we have unit differentiation in general. It's very common to find the equation of the normal or tangent. But part A is interesting because we have the parametric equations of x is equal to 4 sine t and y is equal to 2 cosec 2t. And we have the point A, which lies on C, the curve C, and has coordinates 2 root 3 and 4 root 3 over 3. For part A, we need to find a value of t at the point A. So it's important to note that it says the value of t. So it's going to be important. Once we solve the equations, you will see what I mean. Okay, so normally we have the value of t and we find the coordinates, right? But in this case, we have the coordinates and we are expected to find the value of t, which is probably the more involved way, because when you have t, it's very easy to find the coordinates. But when you have the coordinates, sometimes it can be a bit tricky. Okay, so in this case, that means let's just start with the x coordinate. So when x is 2 root 3, we want to know what is the t, the value of t. So it's a trigonometric equation, and so let's rearrange that and divide both sides by 4. So we get root 3 over 2. And then if you find the sine inverse of root 3 over 2, its value is going to be pi over 3. But also we also have another value, which is 2 pi over 3, because remember that the value of pi is between 0 and pi. And if you remember the cast diagram, the regions that we have for the values of t are here and then here. So that's why in order to find 2 pi over 3, we do pi minus pi over 3 to get 2 pi over 3. But I will explain this in detail in the trigonometry chapters, not here, because here is about differentiation and applying that. Okay, so now we know the values of t, but there is maybe a problem, because the question says find the value. So it has to be one value for t. Okay, so what should we do? A very easy way here is that substitute each of these values of t into the equation of y, and you already know that the y coordinate is 4 root 3 over 3. So you substitute each of these t values, and for only one of them, you are going to get the same y coordinate as written here, which is 4 root 3 over 3. So the other one won't give you that value. So with that method, you can find the right t value for this question. So let's start. When t is equal to pi over 3, let's see what happens. So y is equal to 2 cosec 2t. So t is pi over 3. If you multiply that by 2, that's 2 pi over 3. And we want to find this value. So I'm going to use calculator. And that gives me exactly 4 root 3 over 3, which is exactly the same as the above y value. So this is the t value that we want. But I'm going to try the other one, just to make sure we get a different value for y. So when t is equal to the second value, which is 2 pi over 3, so here we'll have 2 cosec 2 times that, which is 4 pi over 3. Let's see what do we get here. And this time we get minus 4 root 3 over 3, which is not what we want, because again the y coordinate is 4 root 3 over 3. So yeah, now we have answered part A, and the value of t is pi over 3. And note that part A only has 2 marks, but if you consider the solution, it's probably a bit longer than maybe 3 marks would be the fair, more fair basically. So now let's answer part B. Part B says the line L is a normal to C at A. Show that an equation for L is that. Okay, so you should all be very familiar with these types of questions by now. In order to find the equation of the normal, we first find the derivatives of x and y with respect to t, and then divide the x and the gradient of the tangent, then the gradient of the normal, and finally the equation of the normal. So the x dt is equal to sine t differentiates to cos t, so it's just 4 cos t, and dy dt is equal to, so cosec 2t differentiates, so cosec t in general differentiates to minus cosec t times cot t by using the standard result. So since here it's 2t, 2t differentiates to 2, so we already have a 2 outside of the function, so it's going to be 2 times, then this 2 that is a derivative of 2t as well, so 2 times 2, and also it's negative by the way, because it just, in the standard formula you have negative cosec x times cot x or t. So yeah, that's why we have a negative here, just part of the formula, and the rest is just so times cosec 2t times cot 2t, which we can write that in a nicer form, minus 4 cosec 2t times cot t, cot 2t. Okay, now we have this, so we can find dy dx. So dy dx is equal to, we do divide it divided by dx dt, so it's going to be minus 4 cosec 2t times cot 2t divided by 4 cos t. So we can cancel out 4 and minus 4. Then we can rewrite cot 2t as cosine 2t over sine 2t, and you will see why in a second. So cos 2t divided by sine 2t. Yeah, the reason is that you have cos okay, never mind, because I was thinking that we can simplify cos on top with cos in the denominator, but yeah, the problem is that we have cos t, and in the numerator it's cos 2t, so yeah, we should be careful. But it's fine, because even if you don't simplify, that's fine, because you just calculate the work at this point, because we want to evaluate the value of dy dx at pi is equal to, t is equal to pi over 3. So when t is equal to pi over 3, dy dx is equal to, so if you substitute that into this very long function, we'll get negative 4 over 3, but we also have a negative here, so it's basically negative 4 over 3, which is 4 over 3 for the value. And note that this is the gradient of the tangent, so tangent, but we want to find the gradient of the normal, which is the negative reciprocal of that. So gradient of normal is equal to minus 3 over 4. Okay, now we have the gradient of the normal. We have the coordinates of A, which are 2 root 3 and 4 root 3 over 3. We can finally find the equation of the normal. So we use the form y minus y0 is equal to m times x minus x0. So we substitute the values. So y0 is the y coordinate, which is 4 root 3 over 3. Gradient is minus 3 over 4. And then x0 is just 2 root 3. Okay, so we have two denominators of 3 and 4, so we can multiply every term by 12 to get rid of the denominators. We'll have 12y minus 16 root 3 is equal to minus 9 times x minus 2 root 3. Then we have 12y is equal to 12y minus 16 root 3 is equal to minus 9x plus 18 root 3. Then since we want to have the equation in this form, so we can bring everything to the left side, we have 12y, then add 9x, then if you subtract 18 root 3, we are going to get minus 34 root 3, which is exactly the same as the question. And yeah, so this is how we can solve this question. Okay, so thank you for watching.